So we go now to the combined heating and humidification of moist air. During winter, atmospheric air may be heated and humidified in processing equipment prior to its introduction into an air-conditioned space. During summer, air passing through a conditioned space absorbs the heat and moisture gains of the space and is heated and humidified. So considering again this figure, we have this heating medium. So we have that Q 1 and 2, and we have a spray here. This is the mass of the water times this is the enthalpy of the water. Okay, that one, the spray. So at state 1 here, this is our state 1. We have mass A1, temperature 1, the W or the humidity ratio, and the enthalpy. Enthalpy 1. And at state 2 here, have the mass 2 there, the T2, W2, and enthalpy 2. Okay, so this is our heating medium. Heating medium. Okay, so let's illustrate this process in this psychometric chart. So this is our psychometric chart here. So at point 1, this is our point 1, and this is our point 2. Okay, so here this is the dry bulb temperature at 1, and this one will be the dry bulb temperature at 2, and this is W2, and this is W1. So we have that H1, or this is H2, and this is your enthalpy 2. So just connect the process from 1 to 2, and that arrow there. Okay, so the process is the combined heating and humidification of moist air. Okay, the figure shows schematically a device for heating and humidifying moist air in steady flow. The steady flow energy and material balance equations are we have mass A1 H1 plus mass WHW plus Q 1 to 2. This is equivalent to mass A 2, enthalpy 2. And of course, the mass A1 is equivalent to the mass A2, and mass A1 times W1 plus MW is equal to MA2 W2. Thus we have this Q1 to 2 is equivalent to MA, it's the mass of air, times the enthalpy at point 2 minus H1, and this is minus MW HW. So MW, this is equivalent to MA times humidity ratio 2 minus humidity ratio 1. So by dividing the equation by dividing this equation, for example this equation here, equation 1, and this is equation 2. So dividing equation 1 by equation 2, we have here Q prime is H2 minus H1 over W2 minus W1, and this is equivalent to Q1 to 2 over MW plus HW. So this equation gives the value of the enthalpy moisture ratio, which fixes the direction of a straight line connecting the initial and final state points for the combined process. The analysis for heating and humidifying from equations 1, and we call this equation 3, may be generalized to apply to any process where heat and or moisture are added or removed. Thus, for sensible heating alone, where MW is 0, the equation 1 in here reduces to we neglect the MW. This is equal to 0 if that is the process is by heating alone, or that is sensible heating. Okay, so we draw this by, we illustrate some example here. We have our sample problem for combined heating and humidification of moist air. Moist air enters a chamber at 40 degrees Fahrenheit dry bulb and 36 Fahrenheit thermodynamic wet bulb temperature at a rate of 3000 cubic feet per minute. Barometric pressure is 14.696 psia. In passing through the chamber, the air absorbs sensible heat at a rate of 153,000 BTU per hour and picks up 83 pounds per hour of saturated steam at 230 Fahrenheit. Determine the dry bulb and thermodynamic wet bulb temperature of the living air. So we have our solution. So again, by determining those values, so the use of our psychometric chart, we have this W1 0.00359 this pound W over pound of air. We have H1 is 13.47 BTU per pound air. And we have this specific volume 1 12.66 feet cube per pound, and this is per pound air. So we have the mass air is, this is 3000 over 12.66. So we have an answer of 237 pound per minute. Okay, and using the equation here we have this W2, this is equivalent to W1 plus MW over MA. So have the 0.00359 plus 83 83 over 237 times 60. No, this is 60. Yes, 60. So this is W2 here. That is 0.00943 pound W over pound A. Okay, using also the equation to discuss, we can determine the H2. This is H1, that is Q1 into over MA plus MW over MA HW, and this is equal to 13.7 plus 153,000 over 237 times 60 plus 83 times 1157.02 over 237, and this is equal to, our H2 is equal to 30.98 the unit is in BTU per pound. Okay. So state 2 is established by the intersection of H1, H2 and W2 using our psychometric chart. So the intersection of H2 and W2. So we have the value of H2 and W2, and thus we have the value also. You can determine T2. This is 85.8 Fahrenheit, and you have this one. The temperature wet bulb, or the wet bulb temperature, is 66.4 Fahrenheit. Okay, but give you we have the alternative procedure in solving this by using the psychometric chart. So use the protractor. Okay, you use the ASHRAE psychometric chart. So here you have this one. You have Q prime is 153,000. This is 83 over 83. This plus 1157.02. This is 3,000 BTU per pound W. So this is our psychometric chart here. Okay, so this one, okay, so you have that Q prime using that protractor. Okay, this is your 3,000. So you have the Q at 0.1. This is your 0.1, and this is your 0.2. Okay, so okay, so this line here will draw here. So this line here is parallel from line 1 to from the line 1 2. So this one is parallel to this one. Okay, this is parallel. Okay, so have this is 40 or T1, and we have our T2. This is 85.8. This is in Fahrenheit, and you have this dry bulb temperature, wet bulb temperature, I mean. This is 66.4 Fahrenheit. So by time you can also determine this W and this W1 here. W1, W2. So W2 is 0.00943 pound mass of water vapor and per pound mass of dry air, and W1 is 0.00359. Pound mass of water vapor over pound mass of dry air. So this is the illustration of using the psychrometric chart and a protractor, using the hash array psychrometric chart. Through the use of two straight edges, draw a line through state 1 parallel to the line on the protractor. For Q prime is equals 3000 BTU per pound W. The intersection of this line with W2 is equals 0.00943 locates state 2. We find T2 therefore equivalent to 85.8 and T2 wet bulb, this is 66.4. so we have this T2 85.8 and T2 66.4 for our thermodynamic wet bulb temperature. So that is the alternative solution or process in solving those our sample problem.